Thank you all for coming. So this talk is called The Long Road to Async and Await in JavaScript. If you're looking for the quick and easy guide to async and await, that one's down the hall. Of course, my name is Thomas Hunter with the 2, don't forget it. My Twitter handle's in the lower left corner if you're into that. And I currently work at a company called Intrinsic. And so we do some pretty cool node security stuff. You know, we mess around with the internals of the node APIs and the JavaScript language. We work with some really gritty, cool stuff. So yeah, hit me up if you're looking to secure your node applications. Also, last year I wrote a book called Advanced Microservices. I don't know if we have enough time for questions, but if we do, the person who asks the best question gets a copy of the book. If we don't have enough time for questions, hit me up in the hallway, ask me one, and I'll probably just give it to you. Cool. All right, so throughout this talk, we're going to look at what I sort of call the evolution of asynchronous control flow as it exists in JavaScript. And so I'll sort of break this down into a few different phases. And so hopefully these phases look familiar to you. Phase 1 is callbacks. Phase 2 is promises. Phase 3 are generators, which have their yield keyword. And then phase 4 is async and await, which everybody's probably looking forward to. But first, I tricked you. We're not going to start with phase 1. We're going to start with phase 0. And so phase 0 is synchronous code. And so, of course, it's by its very nature, it's not asynchronous, but it is a good starting point for us to look at. So in this example, this code example is what we'll explore throughout this presentation. So in my humble opinion, this sort of represents the simplest, most succinct way to interact with functions, call functions, get the return values, and essentially write code in JavaScript. It's pretty simple stuff right here. So what we're doing in this case is we're calling this function called sendMessage. And so sendMessage accepts 2 arguments. The first one is the identifier of the user. The second one is the message that we're going to send. And once the sendMessage function call is complete, we then get the result of that function call. And the result is whether or not the message was sent. And then finally, we log that message to the screen. So of course, within the function, we call a few other functions as well. So we accept the user ID. We pass that into the getUser function, which is itself also a synchronous function. Synchronous, of course, meaning that this code executes in the same stack. Code executes sequentially. We're not running any other code intermingled with this code. So once the getUser operation is complete, we pass the result of that into canSend. And so the getUser function perhaps looks up the user from some sort of database. The canSend, maybe that makes another database lookup. Maybe it talks to a third-party service. canSend tells us if the user is in fact able to send a message. If they are not able to send the message, we return a false value. And so the overall sendMessage function returns that false, and then we log that to the screen. However, if the user is able to send a message, we then pass the user object and the message into our writeMessage function, which finally does something with that message. Perhaps it puts it in a database. Perhaps it actually sends an email. And then once the operation is done, we return the result of writeMessage, which is, of course, what the overall sendMessage function returns. So when we have to handle errors in these with synchronous code, what we do is we wrap these function calls in try-catch blocks. Has everybody written try-catches before? Just checking. Most of us. So what you do is you wrap your function call in a try-catch. Within the actual function itself, you're able to throw an error, and that error gets caught in the calling environment. So in this case, our sendMessage throws the error, some bad stuff happened. That triggers the catch block, and we return a log to console error instead of running our normal console.log afterwards. Cool. So pretty standard stuff. This thing's dead. All right. So now we're going to look at phase 1, callbacks. Who uses callbacks? Yep, hopefully. Every one of you. Cool. So this is what our callback code looks like. You're probably wondering what these little emojis are doing in the code. Of course, that would be a syntax error. But But these aren't actually part of the code. They're simply annotations that I've put inside the presentation. So anytime you see one of these little clocks, it means that this is work that's scheduled to happen in the future at a later time in a different stack. And so that's where the asynchronous nature of JavaScript comes into play. We perform a bunch of work in this current stack, and once we're done, we're able to grab work, which is then scheduled at some point in the future to be executed. So in this case, what we do is we now modify our send message function. Instead of accepting just the username and the message, we now accept a third parameter. And this parameter is a function. And we refer to this function as a callback. And so specifically, we say, hey, execute this function sometime in the future. And in Node, which is my, Node, of course, using lots of callbacks, they sort of invented, I think they invented the pattern, where the first argument is an error and the second argument is the data that you're actually looking for. Of course, this works in browsers as well. So in this case, inside of our send message function, we take that user ID, we pass it into the get user function, but this time we're also passing another callback into that function. And so once the get user function is complete, it's going to execute our callback. It's going to call can send, passing in the user value that we got from get user. Once that's complete, it's going to call the next function. It's going to check to see if the user is able to send a message. If not, this is when we finally call the original callback passed into our method. And so what we're going to do is return the value false. The first parameter is a null, which is signifying that no error occurred. And then we return, and our function is done executing. Otherwise, if the user was able to send a message, we're going to pass that message on to write message, along with our callback, and of course the user object. And then we leave it up to the write message function to call our callback with the result of the operation. So of course, once that's finally done, we finally get back to our original calling environment, and we log the result. Of course, I didn't show any error handling in that previous slide, and so this is how we handle errors with the callback pattern. If an error occurs, you do something with that error. Otherwise, you continue running code as usual. So within our send message function, I'm no longer throwing an error. If I did throw an error, that would cause confusing behavior. You would need to wrap your send message call in a try catch. If you do that in Node land, people aren't going to be too happy. So what you do is you call the callback, passing in an error as the first argument. One thing to notice, though, is that I've actually wrapped the call to callback in a set immediate. This executes the callback in the future in a separate stack instead of the current stack. If you sometimes execute callbacks in the current stack and sometimes execute them in a future stack, it'll lead to confusing behavior, and users of your libraries will not like you. Cool. Of course, when we actually get errors, we need to handle them. And so a pretty common pattern in Node is that within each one of these callback functions, if an error occurs, this is sort of the simplest way to do the error handling, is you would then fail the overall callback with the error object. So this is just the simplest, most straightforward way to do it. Of course, you could do more fancy stuff. Perhaps if an error happens in the can send screen, you would perhaps log the message to a database before returning. But this here just represents the simple way to handle errors. All right, so phase 2, promises. Who here uses promises? All right, most of us, but definitely less than those who use callbacks. So promises were introduced in ES 2015. It does not introduce a new syntax, which means it can be completely polyfilled. And so, for example, a lot of people have probably used Bluebird. Actually, who has used Bluebird here? Cool. All right. So Bluebird allows us to run promises on technologies older than the ones listed here. All right. So promises. When we use a promise, we don't pass in, another argument. For example, with the callback code, our final argument was the callback function. However, with promises, we actually use the return values. One thing to keep in mind when we were looking at the callback code is that at no point in time did we actually use any of the return values. We would simply throw them away. So if we think about functions being this important basic feature of JavaScript, when we use the callback pattern, we sort of ignore half the features of these functions. So, function accepts arguments into it and then returns data from it. However, with callbacks, if we're using that pattern, we're simply using the arguments to functions. We're not actually using their return values. So with promises, however, we do use the return values. So each one of these promise functions will then return a promise object. And these promise objects have methods on them. So one of the methods is then. So in this case, when we call send message passing in arguments, the first thing that we do within that send message function is return a call to get user. And so that get user call is returning a promise. And then so the overall send message function itself is also returning a promise. So on the first line, when we call that dot then and we pass in that callback, we're saying once this entire send message process is complete, I want you to execute this function that I've specified. So then send message, our get user function is executed. And then once that is complete, we call the function that we've passed in after it. I wonder if this laser works. Cool. So once this get user function is called, we then call this function here, which accepts the user. We return another call. We pass that user object into the canSend method. CanSend is a promise again, and once that promise is resolved, this then is now complete, and we're able to move on to the then, which then follows, which is itself another function. Within that function, if the user is not able to perform this operation, we'll return a false. And so within one of these thenable functions within our promise chain, if we return a normal value, that is what the promise will resolve to. However, if the user is able to send a message, we will call this write message function, which is itself, as you probably guessed, another promise. And then the resolved value of that promise is what the overall promise chain resolves. And so I say promise chain because it's really, we have like 3 or 4 promises going on here. And so each time you return a promise within a promise, in a sense, you're adding a new promise to this promise chain. Now, when bad stuff happens in promises, we don't refer to it as throwing an exception. We refer to it as rejecting the promise. So the syntax for that looks like this. We call our send message function. Again, we have this dot then, which accepts a function. However, that's not going to run in this situation. Instead, the catch is going to run. So within our promise function called send message, what we're doing is we're returning a promise which rejects. And so what this will do is it'll call that catch once the promise has completed rejecting. Cool. All right, so phase 3, these are generators. Raise your hand if you have used generators. All right, there's like about 10 of us. Now, of you who raise your hand if you completely feel that you understand generators. It's like 3, 2, 3, 4 people. All right. So the thing about generators is that they're extremely powerful. You can do so much stuff with them. However, they were never completely properly understood. Right? Confusing. They do introduce a new syntax, which means you cannot simply polyfill them. However, you can transpile them. Generators are part of the ES 2015 spec. And in Node land, they were first available in Node version 1, which didn't exist. It was actually called IOJS version 1, as well as these other lovely technologies here. All right, and so this is the syntax of generators. It's very scary, and it's scary looking on purpose. So we're going to look at a scary example, and then on the next slide, we'll look at a simpler example. So one of the example use cases of generators is using it to perhaps output an ever-growing series of numbers. Like, I don't know, Sierpinski triangle calculation type of stuff is sort of the go-to example for these generator functions. However, we're actually able to sort of hijack them in a sense and use them with promises. And, that's why they earned a place in this asynchronous control flow presentation. So our send message function in this case is a generator. We can see that it's a generator, of course, by that asterisk between the function and the function name. And so within our function, we see that we have these yield operations. So the cool thing about generator functions is that they're able to pause execution in the middle. So as we execute this send message function, when we get to these yield operators, we're able to continue executing code somewhere else in our program, and then eventually we're able to jump back into the generator and continue where we left off. All right, so now I'm going to try to step through this code. It's going to sound a little confusing, but don't worry too much about that. So the first thing we do is we execute our send message function, passing in our 2 arguments. Send message is then going to return this generator to us. That generator is assigned to this gen variable. What we do is we call gen.next, and what this is doing is it's stepping through this generator code. Within the generator code, we accept the user ID and the message. We pass the user ID into get user. In this case, get user is it's just going to be a promise. And then so the get user function is going to return that promise to us. We're then going to yield that promise from the send message generator function and then return back to our calling environment. So in this case, once we've done that, we then accept the value that was returned from the generator, which is a promise. We then call then on that. And then so we pass in this function. So once that promise resolves in the future, our function is executed. Within there, we call the generator again. So notice how we accept within the calling environment, we accept the user variable, and then we pass it back into the generator. So there's this interesting pattern with the generators in that we're taking things out, resolving them, putting them back in. So it's this interesting back and forth between our calling environment and the generator. And so as you can see, this requires intimate knowledge of the generator within my code. So each time we're yielding an operator, each time we're yielding data from the generator, I need to know about it in my calling environment. I then pass it back into the generator. So if I were to add a few more yield lines within the generator, I would need to add more and more of these crazy nested functions. But of course, this is the bad, scary example, just to kind of explain how it works. So now let's take a look at the not so bad and scary example. So this pattern of resolving promises, putting them back in, resolving promises, putting them back in, of course, that can be automated. One such library which makes this automation of that process convenient is the co library. And so what co will do is it will actually wrap a generator for us, and then it will return a promise. That promise will resolve once the generator is complete, and it will take care of yielding or resolving these promises and passing back into the generator for us. So in this case, we see that we have the same call to send message where we pass in the 2 arguments. And again, since it's simply a promise, we're going to call the then method, and then once it's done, it's going to call our function. So these second, third, and fourth lines here look exactly the same as they did in our promise code. Now within our send message function, you can see that we're now returning a call to the co library, which has wrapped this generator function. And so this code looks much simpler. We don't have to deal with that back and forth manually. Now the cool thing about co is if at any point in time one of those promises will reject, then the overall co promise itself will reject. So the example code I showed you earlier was very flimsy. I think it would just explode and stop working if a rejection were to happen. However, with this co library, it makes it convenient for us. So again, the send message call with our then method and the catch method is exactly the same as with the promise code, but we have this sort of simpler call to the code generator. All right, cool. The part you've all been waiting for, I hope, unless you're excited about generators, is async and await. So raise your hand if you use async and await. Raise your hand if you're using it in production, non-transpiled. Nobody. Oh no. Okay. So it's pretty new. The support is still getting there. Of course, it is a new syntax which can be transpiled. It cannot be polyfilled. It was available as of ES 2017, as well as this slew of technologies here. So here's what the syntax looks like for this. One thing to keep in mind is that as you're looking at this code, there is we have an immediately invoked function execution. This anonymous function which is wrapping lines 2 and 4. So I'm talking about this thing here. So the reason that we have to do that is that we're not able to use the await syntax within a function if that function is not an async function, which is the dumbest way of putting that. You need to use await inside of an async function. That makes a lot more sense. So for example, if you're using like a REPL, if you're loading a script in a browser and you're just executing code in the top level of the script, or if you're requiring a file in Node, each time you execute code in that situation, that code is not actually within an async function. And so this is why we're wrapping it in this async function here. It just makes these presentations work a bit more. It makes these presentations make sense, essentially. So within this immediately invoked function execution, we call the send message, passing in the arguments. This time we're going to use this await syntax. And so what that means is, once the call to send message is complete, I want you to continue executing my function up here. So now that we've called this method here, we're actually going to hop down and start running code. So of course, send message is an async function. We know that because it's got the word async before the word function, whereas generators had an asterisk between function and send message. Actually, that makes me wonder if you can have an async generator function. Who knows? So yeah, in this function, what we do is, again, we accept the user ID in the message. And of course, this code should look a lot like our original synchronous code did. So really, there's only a few differences going on here. So we don't accept the third callback argument, and we are using return values. And so this code looks a lot like our synchronous code. So when this code runs, the first thing we do is we take the user ID, we pass it into the getUser function. GetUser is itself also an asynchronous function. Once that function is complete, perhaps it's going to a database, retrieving it, and then giving us the result. So once that operation is complete, we're then able to pick up where we left off. And so the value of that will be assigned to the user variable. And then again, we step to the next line. We call canSend, where we pass in the user. We await the value of that. Once that function is complete, we assign that variable to able. If the user is not able to send it, we return a false. And so the asynchronous function, if at any point in time you return a simple value, that value will be what the asynchronous function ultimately returns. However, if we are able to send, we will then make another call to the write message function. Write message is, again, an async function. And then once that is complete, the result of write message will be the result of the send message call. One thing to keep in mind is I'm not doing a return await write message. I'm simply doing a return write message. And so under the hood, these async functions are smart enough to wait for that write message function to complete before it returns the value. You can actually write return await write message. It does work, but your linter or coworkers will tell you that the syntax for that looks bad. Cool. All right, and then so how do we handle errors? I'm glad you asked. And so what we do is our calls to our anytime we call an async function and we await the result, we can wrap that in a try-catch. So again, this code here looks a lot like the synchronous code that we were writing in the first slide. So in this case, within our async function, we're now able to throw an error. If you throw an error within a callback function, bad things will happen. However, with the async and await, we're able to throw these errors, and we're able to properly catch them and continue on merrily. So in this case, it works exactly as you'd expect. The error is caught. We log it through console.error, and since we return, we don't log the result to console log. Now the cool thing about async and await is really just promises. So what that means is any point in time you have an async function, you can simply swap it out with a promise. You can await a call to a promise. If you call an async method, an async function, you can then later call the .then property of it. So async and await is totally interoperable with promises. So let's look at some code examples which sort of proves that. So in this case, perhaps we have an existing code base already written in promises. And so I've worked on a lot of these myself. And so there's perhaps two ways to refactor a code base. And so you can do it from like the bottom up or the top down. And so when I say top and bottom, really what I mean is the top layer of your application is the most shallow layer. Perhaps it represents like an express controller. That is like the entry point into the system. Whereas the bottom part of the application is actually, the deeper regions of the application. So your model code, for example, would be the bottom. So in this case, what we want to do is we want to do a refactor from the bottom up. And so we're going to keep our existing promise code in the controllers, which we see on lines 1, 2, and 3. However, our send message model code, we've now rewritten to be an async function. So again, the send message function at the bottom is exactly the same one we were looking at on previous slides. And then the send message promise code on the top is exactly the same as we saw in the promise section. And so we're able to call the send message async function. We call the .then. We're passing the function to get the result. So they're completely interoperable. And then so the error handling works exactly as, well, maybe not exactly as you'd expect, but it works in a good, happy way, I suppose. So within our async function, we're able to throw an error, and then within our promise code, we're able to use the .catch method to get that error. And of course, we can also refactor from the top down. So perhaps within your express controller, you've modified your route handler to be an async function. Within that code, you're able to await calls to your send message, your deeper model code. And then our send message code is still the exact same promise code that we had before. And then this code works together just beautifully. And then when handling errors, if within a promise function you reject that promise, that will trigger the try-catch wrapper that we have within our async function. So errors are totally compatible as well. So how many of you use Node? Awesome. Me too. All right, so the Node API, of course, uses callbacks. It is the pattern that it uses everywhere. It's a really, really nice pattern. However, now that we have async and await, this pattern here is also pretty nice as well. So there are sort of two ways that you can promisify methods. The first one you can use, there's this built-in utility called util.promisify. So what you can do is you can pass into it a method which normally accepts the callback pattern. So of course, fs.readFile, for example, is a function which will obviously read a file from the file system. And so this function accepts 2 or 3 arguments. So the first one is the path to the file to be read. The second one is an options argument. And then the final parameter is the callback function that you want to call. And so if you want to be able to use the async and await syntax within your code base, but you want to work with these native APIs, that's why you're going to want to promisify these methods. And so what this util.promisify will do is it will take that method, it'll wrap it in a promise, and then this promise is smart enough to look at the arguments, and it knows how to call the callback properly. And so now this variable that I've created called readFile, this is now a promiseified version of fs.readFile. And so that's a great way to do it if you're working with singular methods. However, a lot of times we need to work with perhaps an entire library. So one of my favorite tools is one called Redis. It's like an in-memory database. The thing about Redis, though, is it has maybe 100 methods, probably more. And so the thing is, if you wanted to promisify each one of those methods, you'd have to go through one by one. It'd be pretty painful. And so in this case, I'm using a library called pyfall, which I believe stands for promisify all. And then what it will do is obviously promisify all the methods of an object. So in this case, I'm passing in the entire FS module into promisify all. And then every single method within that object will then have a sibling method. So in this case, it has modified the FS module, and we now have a read file async method. And so that async suffix is added by promisify, or is added by pyfall. So in this case, now I'm able to await these calls to read file that I've manually promiseified, as well as read file async that we've promiseified with pyfall. And then we're able to log the message at the end. Can anybody spot the anti-pattern? Yep.
So we are reading stuff.txt and we are waiting until we're done. Then we're going to go read data.txt.
That is exactly right. So I just kind of wanted to point this out, that async and await makes it super easy to to write this syntax here. So yeah, exactly what it's doing is it's waiting for the first one, and then once it's done, it's waiting for the next one. But of course, we live in non-blocking, amazing I/O land, and what we want to be able to do is you perform these operations in parallel. So for example, if each one of these operations takes 3 seconds, the code on this page would take 3 seconds to complete. And of course, there are utilities out there that make it easy for us to do this stuff in parallel. One such example is promise.all. If we pass it an array of either promises or async functions, same thing, it'll wait for the final one to complete, and then the overall promise will resolve an array of those promises. It'll also, as soon as any of the promises fail, the overall promise will reject that failed value. Cool. That's that. Hit me up on Twitter. I think I have another 15 minutes. I think I have time for questions. So yeah, does anybody have any questions? Yep.
How would you
So if you have an incoming request. Yep. So if you have so the question is, if you have a simple GET request within an application, how do you do that with async await? And specifically, you're talking about perhaps you have an Express application and somebody has a request coming into it. I'm pretty sure with Express, so if you're using like app.get, where you pass in the first argument is the route specifier. I believe then for the second argument, you can simply use an async function. I think that's correct. Actually, does anybody know if that's correct with Express? That's okay, cool. I don't think it was always that way though. Yep, so you'd simply use an async function as the handler for that request. Yeah, the .next call is how you interact with the generators. Yeah, it's not code that I had written. And there's a bunch of other properties on those methods, I believe. I'm not entirely familiar with it. I'm one of those that didn't raise my hand for the question about familiarity with generators. Anybody else? Yep.
In the interest of
Yeah. What is the relation between callbacks and promises? Under the hood, promises are just calling callbacks. Again, since it didn't introduce a new syntax, you can then create your own promises using several lines of code. And so a promise is it's a state machine. It's let me think. How do you describe that? So promises are able to call your callbacks for you when things are completed, like in the future. They keep track of whether or not, for example, you can never resolve a promise twice. I don't think you can reject a promise twice. And so they have some machinery under the hood that keeps track of the operation. But yeah, promises are just these complex objects which encapsulate callbacks and then execute the appropriate callbacks at a future time. It's a way to get a return value from a function and hold on to it, and it sort of represents a callback which could execute in the future. Oh, will they build a cancel into the promises? I'm not too sure. I've heard some rumors that they might. So for example, if you make an outbound HTTP request and it takes like several seconds to complete, maybe 5 seconds in you want to be able to cancel that, which I believe is what you're referring to. And the question is, will that become part of the standard? Yeah, I'm really not sure. It would be cool, certainly, but I'm not sure. Yep. Because it's beautiful. Because like the code for this. So earlier on, we looked at our sort of idealized example with our synchronous code, where everything is left aligned, and you're obviously stepping through the code one by one. These async and await functions get us much closer to that sort of simple idealized syntax. With callbacks, you often find yourself in like the pyramid of hell. Or actually, I guess from your point of view, it would look like this. And then when I write promise code, I find myself in, I like to call it the zigzag of hell. But these async functions get us closer to this perfect, beautiful lineness. Yeah, I know, it's a nice syntax. It makes it easier to do async stuff. Yeah, it's cool. we don't need it. It doesn't really give us anything we didn't have before. We're still able to do the same async work. And then async in a way is technically less powerful than generators, but the syntax for it is just so nice, I think is why we got it. Oh, okay. So what is the difference between async and synchronous call? Ooh. Yep, yeah. So these lines here, how is this different from the synchronous example? It's a great question. So normally when code executes synchronously, it executes within a single stack. The JavaScript language is single-threaded, and so you're only able to do one thing at a time, in a sense. And so what that means is like if you're crunching a bunch of numbers, if you're doing a lot of CPU-intensive work and you're within a single stack, that means nothing else in your application can happen. So in this case, if our read file operation took like 1 second to complete, and if we did this when we did the synchronous version, that means the entire application is frozen. No other operations are able to complete within our application. However, when we await this call, we await the read file function. This asynchronous function at the bottom is essentially frozen, but then other operations within the application are able to continue happening. So for example, if we had like a request app, as we wait for this read file to execute, other users are able to make requests and then get the data that they want. Good question. Yep. So you're talking about to do these two in parallel is the only way to do it using promise.all. Yeah, I don't think there is a way to do this without using some sort of helper function. Like I don't think there is a syntax built into the language which allows running these promises in parallel without the help of a tool such as promise.all. If anybody else knows to the contrary, please let me know. Awesome.
Async await, it's a part of JavaScript already?
Yep, yeah. So async and await is part of JavaScript. It's built into the latest version of the language, ES some number 2017, ES8. So yeah, it's available in these technologies, so browsers and Node alike.
Right, but right now it's only transpiled.
I mean, well, if you need to support Chrome 54, you would need to transpile it. But if you, if the minimum number of, if the minimum technology versions that you need to support are listed here, then you can use async await right now. Yeah, the question is how many stacks can you have at the same time? As far as I know, I don't think there's a hard limit. There probably could be. It's probably constrained based on the amount of memory your application has access to, I would guess. It could be, I don't think JavaScript itself has a limit. Like, for example, it limits 1 million parallel stacks. I don't think it does something like that, but the individual browser engines might have implemented their own rules. For example, if you ever blow up a stack with recursive functions because you exceed 1 billion frames in your stack, you recursively called over 1 billion line functions, that limit there is actually decided on a per browser basis. And so IE, Safari, and Chrome, I think they all have different numbers. And so I wouldn't be surprised if the limit for the number of stacks you can have, perhaps is also based on a browser. Oh, is there built-in protections to prevent you from just blocking the event loop? No, there's not. You could still, within your code, you could have a while true, or you could have it's definitely possible to still, write code that just blocks everything. There's no way around that. If you did want to get around that, you'd need multiple instances of a JavaScript engine running. So for example, Node, you could use the cluster module or whatever, or web workers in the browser. Cool. So many questions. Anybody else? All right, cool. Thanks for coming.